Everyone is watching the wrong bottleneck. The race for AI is measured in chips, H100s, Blackwells, who has the most GPUs. But the real ceiling isn't silicon, it's electricity. A single new AI data center now draws about 1 gigawatt, as much power as a nuclear reactor or a mid-sized city. And the companies building them are learning a brutal truth. You can buy the chips in months, but you cannot conjure the power. Three numbers decide whether the AI boom keeps the lights on or hits a wall. By the end of this video, you'll know what they are, who actually solves the problem, and why the winners may not be the names you expect. Start with the demand curve because it is genuinely staggering. Global data center electricity is set to roughly double from about 485 terawatt hours in 2025 to 950 by 2030, around 3% of all the electricity humanity uses. The AI slice triples. In the United States, data center power demand climbs from roughly 76 gigawatts this year to 134 by 2030. That single sector will drive almost half of all U.S. electricity demand growth. And by 2030, data centers are projected to consume more power than every energy-intensive factory in America combined. The grid was not built for this, and it cannot be rebuilt on AI's timeline. That gap is the whole story. First number, 1 gigawatt. That's the new unit of AI. A flagship training campus now pulls a full gigawatt from the grid, the output of a large nuclear reactor, enough to power roughly 800,000 homes, dedicated to a single building full of chips. Why so hungry? A modern GPU rack can draw 100 to 150 kilowatts, 10 times a conventional server rack. And for every watt of compute, you spend more watts moving heat. Stack tens of thousands of accelerators, run them flat out around the clock, and a campus crosses the gigawatt line. The money matches the appetite. The biggest tech companies spent over $400 billion on this build-out in 2025 and plan to raise that by another 75% this year. And it concentrates in Virginia, the data center capital of the world. These facilities already eat more than a quarter of the entire state's electricity. The chip shortage gets the headlines. But a chip is useless without a gigawatt standing behind it. Second number, 10 years, because here is the wall. You can build a data center in about 2 years. You cannot add firm, clean power to the grid in 2 years. A new nuclear reactor takes roughly a decade from plan to power. High voltage transmission lines take 5 to 15 years and endless permitting. Even the large transformers that connect a site now carry multi-year back orders. And the queue to simply plug into the grid stretches years long in every major market. So the timing collides head-on. AI needs gigawatts in 2026 and 2027. The grid answers in the 2030s. Utilities won't build ahead for a customer who might cancel, and the AI firms can't wait for the utility. This is why you keep hearing that power, not chips, is the real constraint on AI. Megawatts that physically arrive on time. When demand moves at the speed of software and supply moves at the speed of concrete and steel, something has to give. What gives is where the real story turns. So how are they getting power anyway? By going around the grid. In the last year alone, big tech signed contracts for more than 10 gigawatts of new nuclear capacity. Microsoft is paying to restart 3 Mile Island. $16 billion, 835 megawatts, targeted for 2028. Amazon is spending over $20 billion to turn a nuclear plant into an AI campus. Google backed the first corporate fleet of small modular reactors. Meta locked up as much as 6.6 gigawatts across 3 deals. They're building behind the meter, generating power on-site beside the servers, bypassing the queue entirely. But nuclear is the patient bet, and AI is impatient. So the real stopgap is the one nobody puts on a sustainability slide: natural gas. Gas turbines can be online in about 2 years, not 10. Some developers are even pouring gas plant foundations now and promising to swap in a small reactor later. A gas-to-nuclear bet. The scramble is real, the checks are enormous, and the message is clear. Whoever controls firm power controls the pace of AI. Now the part the press releases, skip. This power isn't free and someone absorbs the cost. Start with your electricity bill. In data center hotspots, Households are already seeing rates climb as utilities build out for hyperscalers. Then emissions. Every gigawatt of gas burned to bridge the gap quietly walks back the same company's net zero pledges. Then water and land, strained by new plants and cooling. And the nuclear savior? Small modular reactors are still mostly unbuilt. The first U.S. units arrive around 2030 at the earliest, and the economics at scale are unproven. So the honest scoreboard isn't measured in teraflops. It's measured in two things: dollars per kilowatt hour and gigawatts delivered on schedule. Reliability, firm power, available the day the racks switch on, is the real currency now. The companies that win the AI race won't simply be the ones with the best model. They'll be the ones who locked up electrons early at a price that doesn't eat their margins. Compute is abundant. Clean, firm, on-time power is the scarce resource. So who actually wins the energy wall? On the AI side, the honest answer is the hyperscalers with the deepest pockets and the earliest power deals. They buy their way around the wall. But the real verdict, the one this channel exists for, is who gets paid no matter which lab wins. Winner 1. The turbine and equipment makers. Every gigawatt, gas or nuclear, runs through a handful of suppliers. Companies like GE Vernova that build the turbines the whole world is suddenly fighting over. Winner 2. The power producers. The nuclear and independent operators, Constellation, Vistra, and their peers, went from unloved utilities to the gatekeepers of AI, signing 20-year contracts at premium prices. Winner 3. The unglamorous grid, transformers, switchgear, transmission, the physical plumbing of electricity, all sold out for years. Performance per watt was the old game. The new game is watts per dollar, delivered on time. The AI race was never really about chips or even models. It is an energy race. And in an energy race, the people who sell the energy win. That's the energy wall. The numbers, not the narratives. 1 gigawatt per data center, 134 gigawatts for America by 2030, and 10 years to build the clean power it needs. The actual semiconductor industry view is simple. AI has always been a supply chain story, and the deepest link in that chain is the electron. If you want where this goes next, AI compute leaving the planet to find power and cooling, watch the orbital data center breakdown on your screen now. And subscribe so the next deep dive finds you. The AI race is decided in the supply chain. Here we keep score.